Good afternoon, ladies and gentlemen, here in Silicon Valley, 11th Cloud Expo, now reaching day 4 and the afternoon thereof. So we're getting towards the end of the conference now, but that doesn't mean we haven't got more good content. In this case, if you wanted to know about sustainable networking innovation, I know just the man. Sujal Das, please, take it away. You have 30 glorious minutes with Sujal. Thank you, sir.
Thank you, Jeremy. Okay, welcome. Can everybody hear me? Okay, thank you. Once again, thanks for coming. By way of introduction, my name is Sujal Das. I'm Director of Product Marketing at Broadcom Corporation. For those of you who don't know Broadcom, a very brief introduction. I don't have too many slides on Broadcom or products. It's more about software-defined networking. It's a little bit of a philosophical presentation on what we believe is needed for sustained innovation. So let me quickly start off introducing you to Broadcom, for those of you who don't know, and then we'll get to the meat of the presentation. So Broadcom is a semiconductor vendor, so we make silicon, and we sell through OEMs. And we have lots of products for wired and wireless communication. Today, our focus is going to be network switching, and network switching as in data centers. Broadcom is a $7+ billion company with more than 10,000 employees. I am based right in San Jose. Our corporate headquarters are in Irvine, Southern California. Okay, so with that brief introduction, let's get into the meat of the presentation. So we're going to talk about software-defined networking, and there's a lot of industry buzz around SDN. And today we're going to focus on what we call sustainable network innovation. So SDN is all about network innovation. There is OpenFlow, there is OpenStack, and there's a lot of different standards as well as industry initiatives going on. But the key reason behind SDN is to enable innovation in the network. Just like there has been innovation in the server space, a la the work in the Linux community, for example. So how does one open up the network switch and enable innovation by a broader ecosystem, what I'm calling collective intelligence here. So that's the topic of today's presentation. Cautionary statement on any forwarding-looking statements I make, please ignore those. So what we'll cover today is SDN and how it's manifesting in the industry, and what is needed for sustainable innovation in this space. SDN is still emerging, and we'd like to take it forward, enabling a very broad ecosystem of SDN applications, as well as enabling all of the values that SDN promises to bring to the industry. So we'll look at how it's manifesting today and what are the requirements for sustainable innovation. We'll go deep into what it takes for collective intelligence or collaborative development, which is really important for SDN. And then we'll sum it up with what exactly is needed to enable this innovation. So to say, a toolkit for true software-defined networking. And finally, we'll summarize. Once again, if you have questions, please hold them, because I just have 30 minutes. I would like to cover all the material, and then I'll be available after presentation to answer any questions. So when you talk about innovation, there are two models of innovation. One is on the shoulders of giants. So this is innovation by the giants of the inventors, the large corporations, for example. For example, in the networking space, Cisco is a giant that drives a lot of innovation traditionally, right? And then there is the other way of doing innovation, which is collectivism, which is a typical example is Linux, where a collection of developers worldwide have helped grow that ecosystem into a very comprehensive solution that is available for servers and various other applications, and can compete effectively against proprietary solutions or solutions built on the shoulders of giants. How is SDN manifesting? So first, let's look at what is SDN. So what I'm showing you on the right-hand side is networking infrastructure. So a bunch of switches connected together, and that comprises a networking infrastructure that connects the servers together in a data center, for example. So what I'm showing you is a bunch of switches connected together in a highly abstract fashion. And the reason one needs SDN is because there's somebody sitting in a centralized node or using a centralized controller wanting to control the network in a centralized fashion, as well as have visibility of the network in terms of the services it provides, and then being able to tie those networking services to applications and enable an application-enabled networking infrastructure. So that's the whole notion of SDN. And the way it's evolving is, first, we have a lot of OEMs that Broadcom works with that are delivering key components within the networking infrastructure, such as policy configuration, health monitoring, topology discovery, and even for OpenFlow, for example, delivering components such as the OpenFlow agent that runs in the switches. Now, there are two models of SDN. One is centralized as an OpenFlow, and there is the other very compelling and evolving SDN model, which is distributed, where the intelligence resides both in the network switch as well as the controller. So what I'm showing here is intelligence residing in the switch, and then of course you have the controller where you could have network virtualization. Very famous example of a network virtualization platform is from Nicira that got recently acquired by VMware for a huge sum of money. And then there is other controllers from OEMs and other large software suppliers. And there's also an evolving ecosystem of sort of open source and collaborative development going on, especially in the OpenStack community, about which probably you heard a lot today, as well as the Big Switch OpenFlow controller effort, and then other automation-related efforts from a company like Puppet or Opscode. So there are a lot of innovation going on, and some on the shoulders of giants, and some in a collaborative way. Now let me switch gears a little bit. When it comes to sustainable innovation using collaboration, I want to go back in history and make an analogy with how electricity evolved and how the ecosystem around electricity evolved. So we started with a simple thing like a light bulb that was invented long ago, and then the use of electricity proliferated into various different applications. What drove us was user empowerment and a broad ecosystem that developed around this notion of electricity. So how has it evolved? It's evolved into utility and consumerization. And it started on the shoulders of some giants, some inventors like Bell, Tesla, or Westinghouse, who did different things to bring electricity to the point where it was ready for the ecosystem, where standards evolved. There were governance that was instituted, and all of this together resulted in a very good consumer experience, what we know today as utility and consumerization. And we believe these are also cornerstones for cloud computing and the SDN ecosystem. So let's go back to the data center again with that backdrop. So how is utility computing happening in the data center? First, the economics of utility computing is already happened in the server world. Big iron mainframes have given way to rack servers, which are much less expensive, much more affordable, highly scalable, lower power, lower OpEx, lower CapEx, easier and more distributed supply chain, as well as a larger pool of resources available to develop on these platforms. And we see an emergence of such utility networking also in network switches, especially with top-of-rack switches and aggregation switches that connect those top-of-rack switches. So just like there were big iron chassis switches that were deployed a lot in data centers, such as end-of-row switches. Things are giving away to use of more fixed form factor top-of-rack switches, for example, which are cheaper again, easy to manage, lower capex and opex, easier and more distributed supply chain, and a large pool of resources and expertise that can work on these platforms. So we see this parallel that is happening in the top-of-rack switch environment that's moving towards what we call utility networking. So SDN and collaborative network infrastructure innovation is causing some sea change to happen in the industry. Going from OEM-only innovation, or what I refer to as on the shoulders of giants, things are moving towards collective innovation. From closed systems, things are moving towards open systems. Again, I'm talking specifically with respect to network switches deployed in data centers. And also moving away from vertical integration to a more vendor-agnostic deployment. And if you look at the network topologies and the things that go inside switches, from big iron chassis that could connect to lots of servers, the network infrastructure has evolved to use of fixed form factor top-of-rack switches, one new form factor top-of-rack switches, and aggregation switches connected together using a flat topology, such as a CLOS network or a layer 3 based ECMP network. And if you look under the hoods of the switches, you'd see that from modular switches that had multiple silicon components and were typically vertical solutions where OEMs delivered a lot of innovation, which were mostly proprietary in nature, things are evolving towards these fixed form factor switches with single integrated silicon that drives a lot of bandwidth and lots of ports. For example, today, Broadcom is shipping a single integrated switch silicon that can deliver up to 100 ports of 10 gigabit Ethernet on a single chip. So a lot of integration, a lot of bandwidth available on a single chip, enabling these fixed form factor switches to scale to unprecedented levels. And finally, the need for off-the-shelf solutions, the emergence of ODMs as a supplier of these switches, as well as OEM switch systems which look very similar in terms of their configuration, just like the server paradigm. So these are some key dynamics that are happening in the network switching environment for SDN, as well as cloud computing in general, that are showing the trends towards utility and consumerization that we talked about in the analogy we looked at with electricity. Now, when we talked about network infrastructure and doing it in a collaborative way and doing it in a vendor-agnostic way, there is always a supremacy battle we'll see in the industry. That there's the vertical and the proprietary. Things just work. So vendors would sell you solutions that are tightly integrated in a very vertical way, and the value there is that it's just going to work. It's going to give you the maximum performance. And then you would also see an open collaborative solutions, such as vendors who are pushing solutions like OpenStack for cloud orchestration in the network. So there is always this battle between proven versus scale, proven with vertical proprietary solutions versus the scale of collaborative, more open systems. What is myth or reality? It's to be seen, but what we see is that anything that has to develop in a collaborative fashion is always a continuum. It just doesn't happen overnight. It has to happen over time. And there are certain ingredients that has to fall in place for this continuum to progress and be successful. So let's look at the collaboration continuum journey with networking. So what I'm showing here is a cloud, which is the collaboration cloud, so to say. And then there's the network infrastructure. So first, the collaboration was a little small, and then came the networking with switches. You know, the big iron chassis came about, And it evolved into some level of collaboration that resulted in a lot of applications, network applications that were built. Then came the fixed pizza boxes, or this top-of-rack standalone switches that I talked about. Those enabled more scale, more utility-based networking scale, and that enabled a further degree of collaboration. Then came how do you connect the switches together? So instead of using proprietary fabrics, a lot of large mega data centers, led by the likes of Google, Amazon, etc., deployed IP-based networking. So they scaled using layer 3 based topologies. They scaled using technology like ECMP for building large class topologies. So these further enabled a larger set of collaboration in the industry. And then finally, with the emergence of open source and the SDN movement that we are seeing in the industry today, we believe this collaboration continuum is going to reach critical mass, enabling a lot of value you would see in the industry in the areas of cloud, infrastructure as a service, mega scale data centers, and even bodies like OpenFlow, Open Networking Foundation, OpenStack, etc., delivering on this continuum of collaboration and bringing us to a critical mass of deliverables and maturity, which will enable SDN to reach full potential. So harnessing collective intelligence. So I want to take another example of how collective intelligence can be harnessed effectively to grow this continuum of collaboration that we just talked about. Wikinomics is a great example of how collaboration results in something, a great source of information for all of us. Going back to the data center, the Linux server is a great example of Wikinomics in action. First, there is extreme collaboration in this space. There's an open compute instruction set, be it x86, which is the most popular instruction set, but there's an evolution of the ARM instruction set becoming available in the microserver environment, for example. And then there is the open operating system, aka Linux. Production-wise, there are commodity components, lots of suppliers, and then there is the original device manufacturers who probably build all of the servers today. Even though you buy servers from OEMs, they are getting built in the ODM, the original device manufacturers from, for example, for Taiwan. Companies like Inventec and Asus and others are very large manufacturers of servers today. And finally, it's all fluid and flat. There are multiple suppliers spanning multiple continents, and there's fierce competition in this space. So this is a great example of Wikinomics in action in the server space. Going back to the parallel between servers and network switches, we have seen the server ecosystem evolve. It's evolved from big iron mainframes, from proprietary servers and proprietary operating systems to have standard x86-based servers and off-the-shelf OS, such as from Microsoft. And then we moved to commodity components, economy of scale. The ODMs came about and started delivering servers. Linux became popular to the point where Linux can now rival Windows in the server space. And then gradual evolution of ARM in this space. And finally, it's all about developers and user experience in the server space. In the network switch, we had big iron chassis switches. We still have them. Proprietary ASICs, fabrics, and proprietary OSs from each OEM. That has significantly evolved now to off-the-shelf merchant silicon and standard fabric. For example, in the top-of-rack switch arena, if you look at 10 gigabit Ethernet switches in the industry today, most are based on merchant silicon, a lot of them based on Broadcom, and they all use a standard fabric. What I mean by a standard fabric is the picture I showed you earlier where all these fixed switches are connected together in a spine leaf topology using a standard layer 3 technology, standard ECMP-based class topologies. There is availability of commodity components, and ODMs are stepping up. In fact, almost 8 to 10% of 10 gigabit Ethernet switch supply today comes from the ODM base. So this is a growing phenomenon that's happening in the switch space, just like it happened in servers. So that's where we stand today. Going forward, what I show as future is the need for a Linux and collaborative development environment on the switch. The need for an off-the-shelf network OS, so to say, on the switch. And then making everything user and developer experience rather than focusing on a specific technology. So these are things that we need to drive towards to make the software-defined networking a reality, something that will sustain and thrive. So let me move to what do we need to make this future happen. So what I'm showing here is as a concept of a toolkit for true network innovation. So first of all, this toolkit should be something that applies to multi-vendor Ethernet switches. It's based on the most widely available Ethernet switch and software development kit, just like the x86 paradigm in the server world. And it should enable direct programmatic access to network resources, provide a very consistent interface across top-of-rack switches and AG switches, and enable development of innovative network applications that can be installed on the switches, just like you can do on a Linux server today. So this is the requirement, and this is an ideal toolkit that should become available in the industry. And what I'm showing here at the bottom is an example of such a silicon available in the industry today from Broadcom, which is deployed very widely in the industry. Getting a little more details into what this network operating system, so to say, that runs in the switch looks like. So what you see here is a switch, a hardware switch, with a switch silicon and some tables, resources in the silicon. And then you have a Linux environment. You have the kernel space and the user space, just like you have in a server. You have a set of switch management software and SDN switch APIs. And then you have a bunch of third-party applications that can be installed, and using an RPC mechanism, they can register to the APIs. And you can enable a very server-like environment. Python applications or C applications can be written by developers and installed remotely into the switch, just like they can do on a server today. So essentially providing a very standard switch programming interface for collaborative SDN application development. Laying out as a stack, we looked at some of these applications earlier. What would be ideal is a switch platform with a common Linux-based networking OS that enables these applications to be developed by third parties, by the entire ecosystem of SDN developers, and that can connect to SDN controller applications developed in the industry, be it from OEMs, be it from software suppliers, OS vendors. And this is an ideal environment where collective intelligence can thrive in the network switch environment. So going back to our consumerization and utility example that we showed earlier with electricity, what is needed is some standards. What is needed is some governance, and then finally, true consumer experience. So standards, one needs a standard switch instruction set, so to say, and a standard SDN API that provides a very common building block for developing these applications. And then governance can be provided by various different organizations, ONF, or Open Networking Foundation, of which Broadcom is a founding member, And there are lots, it's a very large ecosystem of suppliers and end users who are members of this organization, developing standards for SDN specific to OpenFlow. And then there's OpenStack, which is a community of developers. So these are examples of bodies that can provide the necessary governance to enable the move towards utility and consumerization. And when we have all of those things in place in the future, we'll be able to enable utility computing and providing a per application and a per user network metric, or SLA. Going back to the utility model where PG&E can charge you on a per usage, on a per household usage, right? How much electricity is getting used. We'll one day get to that model of the data center operators being able to charge on a per application or even a per user basis. That is true utility computing. So to summarize, we discussed a lot of topics today. We talked about how SDN is manifesting. We talked about the fusion of different innovation models on the shoulders of giants as well as collective intelligence. There are many large OEMs and a lot of innovation happening in those OEM labs in their premises that's driving SDN, as well as there are open source and other collaborative effort happening, for example, in OpenFlow, ONF, or OpenStack, that's driving collective intelligence. We talked about the innovation democracy. High leverage innovation can happen only when there is ecosystems, there's governance that leads to consumerization. Collaborative development and collective intelligence is important for sustainable innovation in SDN. And to harness that critical mass of collective intelligence for SDN, one needs a toolkit for the innovation. And we looked at a concept of a toolkit where network switches that are multi-vendor in nature can run a Linux-based operating system and enable a common SDN API where SDN applications can be developed by the entire community of developers, just like in the Linux environment, and where applications can be innovated, designed by anybody, and can be installed on the switch to provide the greatest value for the industry. So with that, I come to the end of my presentation. I think I still have a few minutes left, so if you have any questions, I'll be happy to answer those.
And let us see if there are any questions. Now you see, people are not going to ask you, Sujal, because you've been so clear. And you've explained more than they could possibly want to know about SDN. Not a thing. Let us...
Not a thing? All right.
Instead... wait, I can see pointing. You see, there is a gentleman right there.
So you point out several areas that's still evolving, but which area actually needs a lot more development and is still in infancy?
Okay. So the question is, I talked about there are multiple areas in SDN that are evolving, and which areas are more mature and which ones are more emerging, correct? So Broadcom's been involved in the SDN space. Back in 2007, we actually collaborated with Stanford, and that's where this whole OpenFlow movement started. So we have worked a long time on the OpenFlow side of things with Stanford initially, then with the community, and then ONF was formed. And today we see deployments of OpenFlow technology as SDN in different areas. For example, there is public information about Google deploying OpenFlow in the WAN. There is deployment of there is OpenFlow solution available from multiple OEMs such as NEC, IBM. So that's probably the most developed ecosystem for SDN. There's also the other way of doing SDN, which is the distributed model I talked about. So vendors like Cisco has released a toolkit called 1PK. That's another innovation that has come from Cisco. And we see Juniper and others also continuing to deliver software. But in terms of deployment, I would say, to summarize, OpenFlow is probably the most used today. I won't say it's very widely deployed yet. It's in small pockets, but it's getting there. Any other questions?
In which case, let us thank Sujal Das of Broadcom for a great presentation.